the differential equations of Coulomb's law. As a general note, if you have a polarization response, it is a vector field of a similar form to E. I'm sorry.
It's kind of a given.
Form. My apologies. Anyway, so we have in the general case.
So is that P or rho?
Where?
P-I.
P polarization. We're still talking about polarization.
That looks okay. Yep.
So what I've done is to generate the situation for the general case. As I said before earlier, we were just dealing with a linear theory where you've just got a first order susceptance. Generally, this is what the real world is like, especially where you have the sort of electric fields that you have in laser beams, for example. And you get non-linear crystal optics. You have to take into account these higher order terms of the electric field, and the summation index, you know, operates over 2, 3, and 4 orders. So you're going from a second order tensor, third order tensor, and higher. Different materials result in the kind of susceptibilities that you can experience. So the P subscript naught I is the instantaneous. Polarization response. That is, some materials already have a polar character to them, even before you do anything to it. Can you think of a material that already has an intrinsic polar character to it, polarization, that doesn't actually need an electric field applied to it before it already has polarity? One of the most famous ones that affects satellite communications in a very profound way is water vapor. The water molecule is intrinsically polar. Because of the dihedral of the hydrogen atoms with respect to oxygen, it has a partial positive pole around the hydrogens and a partial negative around the oxygen. So you've got a partial positive. So there's the negative pole and the positive pole. So you've got a dipole moment already in the oxygen molecule. And this is the basis by which you heat your food in a microwave oven. all the way through to why we have to choose certain communication bands for satellites when we have communication from a geostationary satellite or the constellation of low Earth orbiting satellites for mobile communications, because we have to pick windows where we don't get absorption of our transmission signals. So this dipole will swing to keep in phase with an electric field twice every cycle of the electric field, if it can. When it lags behind, that's the generation of friction or heat. So some materials, like water, have an instantaneous or intrinsic polarization response. Another example would be barium titanate, which is often used in some of the materials that are built into your iPhones and various other components.
Do you use the same methodology in the MRI machines?
Sorry?
I mean, MRI machine, do you use the same concept?
No, similar, but it doesn't work on water. It works on proton spin. It measures the proton spin response.
So it still has a magnetic field.
Yeah, but it's a magnetic field, not electric field. Yeah. So you've got spontaneous polarization response, so they're sometimes called electrets. What I'm doing here is just like we have the term magnet or magnetic material, we can talk about an electret material, because magnetic material is intrinsically magnetic, and we've got these other materials but electrically based that have a polarization response, so they're just called electrets.